Hey guys, in this video I'm going to go through an example question related to applications of exponential functions. Within the question we've got the graph shown is that of the function f, where f of x is defined by the given rule, where q is a constant. Part A. Find the value of q. To find the value of q, we need to use one piece of information provided to us from the graph, and this is going to be the point 0, 0. Meaning, when x is equal to 0, y is going to equal 0. And so if we sub this into the rule of f of x, we can solve for the value of q. And so if we let x is equal to 0 and y is equal to 0, subbing this into the rule of f of x, we're going to get 0 is equal to e to the power of 2 times 0, which is e to the 0, plus q times e to the 0, and then plus 3. Anything raised to the power of 0 is equal to 1. And so this is going to be 0 is equal to 1 plus q plus 3. Simplifying this, 0 is going to equal 4 plus q, and so therefore solving for q, q is going to be minus 4. Part B. Find the exact value of m where m is a constant and m0 are the coordinates of the point where the function intersects the x-axis. And so the point m is the x-intercept of the function f of x. To find the x-intercepts, we let y is equal to 0 and then solve for x. And so if we let f of x equal 0, we can write the equation e to the 2x minus 4 times e to the x plus 3 is equal to 0. Here we've got an exponential equation in quadratic form. And we know this because we've got 3 terms and the power of the first term is twice the power of the middle term. And so to solve this, it's going to be easier if we let a equal e to the x. And so rewriting this in terms of a, this is going to be a squared minus 4a plus 3 is equal to 0, which is an easier form of a quadratic equation to work with. And so factorizing this, we're going to get a minus 3 times a minus 1 is equal to 0. Solving for a is going to equal 3 or a is equal to 1. And so therefore this means that e to the x has to equal 3 or e to the x has to equal 1. Solving for x, we take the log of both sides, and so this means that x is equal to log e of 3 or x is equal to log e of 1. We know that log e of 1 is equal to 0, and so this is going to be 0. And so the function f of x has two x-intercepts, one at x is equal to 0 and one when x is equal to log e3. And since the value of m is larger than 0, then this means that the value of m, which is going to be the x-intercept, is going to be log e3. Part C. Find the derivative function f dash of x. We know that f of x is equal to e to the 2x minus 4 times e to the x plus 3. And so f dash of x is going to be 2 times e to the 2x minus 4 times e to the x. We can take out 2 and e to the x as a common factor, and so we can rewrite this as 2 times e to the x times e to the x minus 2. Part D. Find the gradient of the curve where it intersects the y-axis. Where the curve intersects the y-axis is when x is equal to 0. And so if we let x is equal to 0, to find the gradient we need to evaluate f dash of 0. We just worked out f dash of x is equal to 2e to the x times e to the x minus 2. And so f dash of 0 is going to be 2 times e to the 0 times e to the 0 minus 2. And so this is going to be 2 times 1 minus 2, which is going to be minus 2. And so the gradient of the curve is going to be minus 2 when it intersects the y-axis. And that's it for these questions. If you found this video helpful, then click on the like button or comment below and let me know. And don't forget to subscribe to this channel. And if you're studying maths methods, then log into the Maths Methods Club where you can group questions related to exponential functions and see if you can answer exam questions related to this topic. Good luck, and I'll see you guys in the next video.